So yeah, for anyone watching the recording, hello. My name is Tomislav. I'm a solution architect with Mongo DB. So we're meeting with the epilot team today just to talk about our Mongo DB Atlas cloud database and some of the features and stuff you can do in Atlas. So yeah, I think we can get started here. Let's make this as useful and as interactive as possible, right? So I'm always keen to get questions, and just kind of guide me towards what's of interest and what you would like to understand more about. Yeah. So we shared like a feedback form up front, and we got a few responses. So some of the top features that were highlighted in the responses were Atlas Search and online archive, Atlas online archive. So just kind of cross-checking now, are those features still of interest for this group here? Should we focus on them? Or would it also be useful to kind of maybe just before we go into those specific features, talk more broadly about Atlas, what Atlas is, how things work there, just to kind of set the scene if not everyone is up to date, on exactly what Atlas is, right? So guide me toward, to what the best approach is. So should we start with kind of overview of Atlas, and then we can dive deeper into those specific features? Would that work best?
I would appreciate an introduction to Atlas.
Okay, let's do that. Yeah. So I won't bother you with any slides or anything. We'll dive directly into the interface and look at stuff there. And again, please interrupt me, ask questions, whatever makes sense, just to make this time as useful as possible for you guys, right? Okay, let me share my screen. I'm just not so used to Microsoft Teams, so it's taking a bit to find the buttons and all this stuff. Okay, open share tray. That's probably it. Screen share. How do you select a specific screen? Because I have multiple screens.
Yeah, the first one is the default one mostly, which you are on. So that
okay.
Yeah.
Okay, I see it now. Yeah. Okay. Entire screen, and then I can select the screen. Okay, cool. So this one.
Yeah, that works.
Yeah, you can see that now. Yeah.
We see database deployments.
Okay, yeah. So what I'm showing to you now is the Atlas interface. So once you sign up for Atlas, you get your organization. So that's like a top level hierarchy in Atlas. And typically each customer, each company have their own organization. And then within organizations, you can create these projects, right? So we have projects as kind of environments. So most people would set up like development environment, test environment, QA environment, and then obviously production environment to deploy the clusters inside those projects, right? Because each project has its own like private network, security settings, so you can control a lot of things on the project level, and that all the clusters inside the project would inherit those settings, right? So it's kind of nice way to organize stuff in Atlas and make sure that you're applying correct security configuration to different environments, right? Okay, I just realized I didn't actually tell you what Atlas is for anyone who's not familiar, right? So we are a company. We have engineers who are building MongoDB, writing code for MongoDB database. So we are from that company, MongoDB. And before most of our business was from licenses, selling commercial license MongoDB Enterprise Advanced. So in Enterprise Advanced version, there are some differences between the open source, free, and enterprise version, mainly around security features. But all the performance, reliability, fault tolerance, all that stuff is the same, right? But as time passed, and as trends changed, we realized that most people want something that's kind of more managed. So we created Atlas. So Atlas is what our name for a cloud based managed Mongo DB database, which the whole intention is to reduce the operational overhead, of running MongoDB. I mean, you guys are using cloud solutions, you're using Dynamo, you're using other stuff, so you know what I'm talking about. But just kind of the story behind Atlas, right? And yeah, so this is our main product these days. So all the main engineering effort goes into Atlas, and we're adding a lot more features and things into Atlas. We're kind of trying to build, we call it like a developer data platform. So we're not just focusing on database anymore. It's adding extra features, stuff that could help. We see that it's helpful for people to do things more easily. So just to name a few features, we mentioned Atlas Search before. So we integrated full text search with the database. You don't need to run a separate search engine. That's the main advantage. We have online archive, which is like an automated data tiering mechanism. We're going to mention that later as well. There is a magnitude of other features that are not available in like MongoDB itself, but they are part of the Atlas data platform, right? Okay, so this is the UI for Atlas. What I have here is my demo project, and then you can see there is a number of clusters I have deployed there. 4 clusters. One of them is actually paused. So the whole idea behind pausing is you can avoid wasting money on clusters that you don't need 24/7. So typically some like integration testing or dev clusters that people don't need all the time, you might want to pause them just to minimize costs, because then you're not paying for the compute instances, you're just paying for the storage, which is very minimal cost for that cluster, right? Okay, so let's do you have any questions so far? Am I making sense? Are you still with me? Yeah.
Yes, we are.
Okay, cool. So how I mentioned that there is a lot of settings that are configured on the project level, right? So just one that is typically most important is the network access configuration. So when you use Atlas, we deploy stuff in AWS account that we manage for you. So it wouldn't be in your own AWS account. So we need to kind of offer easy, straightforward integration between Atlas and your applications and your services. So on the network level, we have multiple options here. So from the most simple one, IP access list, you can define IP address or IP address range from where you can connect to Atlas. Because by default, we implement all the kind of security best practices. So there is no outside access to your clusters, to your project. So you need to explicitly enable outside access to be able to communicate with the clusters, right? So it's either IP access list or whitelisting. Then we have the VPC peering option. So if I were to create a peering connection on AWS, I need to put in your account ID. So this would be where your applications and services are running, your VPC ID, and then I can initiate peering. You will need to confirm the peering from the AWS side, and once that is done, you have a private network set up, and you can connect to your clusters in a private way, right? How are you doing these things today when you're using other cloud services? I guess, are you using VPC peering or something else? Can anyone share what's the current situation in epilot? Is there somewhere where you're using VPC peering?
VPC, sorry, I was just writing a message. VPCs, we do have a database, the previous one. This is where we have some configuration, yes, but pretty much we run serverless with Lambda. So most of the time we don't require VPC access. We do have some limited features with VPC, yeah, but not many.
Okay. Yeah, we have a lot of customers who are also using Atlas with the Lambda functions, right? So we have plenty of documentation on best practices, for connection management and like network connectivity and all those things that are relevant for best practices with speaking with Atlas, right? So we can share that documentation with you. Okay, I won't spend much time on this then. Just kind of wanted to mention this aspect. So once you set up all those things, you are able to deploy a cluster. So in terms of deploying a cluster, we have a few options here. You'll notice that we actually support the 3 main cloud providers. It's not just AWS, so you can run your Atlas clusters also on GCP and Azure. And depending on the sorry, I have some sore throat issues today. Depending on your cloud provider selection here, you get a selection of regions that are available with that cloud provider. And this is where we'll actually deploy your data. This is where the machines and the data will reside, right, for your MongoDB cluster. What is the current setup? Where are you keeping the data today? How is that being managed?
Yeah, we have it in EU Central Frankfurt. I was just typing. We need that for GDPR purposes as well.
Mm-hmm. Yeah. Okay. So yeah, Frankfurt is definitely one of the options here. You might ask why there isn't this star aligned with Frankfurt here. So stars indicate recommended regions. So recommended region is where we have at least 3 availability zones available. And in Frankfurt, there is a temporary issue with capacity. So this is not like directly our issue. It's more on AWS side. I know they are trying to rectify this. So the last time I checked, it was in short term they're planning to add more capacity. So we will be able to use 3 availability zones in Frankfurt. 3 is better than 2 because you just have better high availability and fault tolerance of your cluster, right? So availability zone, the way I look at it, is basically a separate data center. So having 3 data centers means, if one data center fails, power, network, fire, flood, whatever, your cluster will be able to survive that because we have at least 3 replicas with each Mongo cluster. So that's a minimum, right? So in Atlas, you can't even deploy a standalone node. We don't play with or mess around with high availability. So it's always a 3-node replica set that we deploy in Atlas. And in these regions which are recommended, we will deploy those nodes on 3 different availability zones, again, for increased fault tolerance and high availability, right? Yeah. So I know that you are focusing on serverless a lot, right? So the main difference here, so between dedicated instance, so I'm now showing you the dedicated option. We do have the serverless option as well, right? So serverless is more, it's not so mature as the dedicated option. So we added it maybe a year and a half ago, 2 years ago, I can't remember exactly. And you can see the choice of regions is actually much more limited, right? So we don't yet support all regions where we have dedicated clusters, where you can deploy dedicated clusters, right? So I expect this to change. We are always looking at customer feedback, customer interest. So when there is interest for extra features, extra regions, and stuff like that, we always kind of react and add that, right? So at some point, I guess Frankfurt will be supported as well, right? Okay, so I would focus on dedicated instances for now because we don't, like I said, we don't really support all the features. So search and online archive are not fully supported on serverless instances. So if you want to use those features, dedicated is the way to go, right? I just don't want you kind of to think that using dedicated is an issue for whatever reason, because vast majority of our customer base in Atlas are using dedicated clusters. So we have thousands of customers, thousands of clusters running in Atlas, and vast majority of them are dedicated clusters. So the main difference is obviously you need to select your cluster tier with dedicated. So we have these cluster tiers. We call them M10, M20, M30, and so on, right? That's just basically when you select a cluster tier, you select specific hardware that comes with that tier. So in this example, M30 comes with 8 GB of memory, 40 GB of disk, and 2 CPU, virtual CPU cores, right? We do support things like scaling, automatic scaling. So when you turn on these features here, storage scaling and cluster tier scaling, Atlas continuously monitors metrics for your cluster. So once, let's say, your disk utilization reaches 90%, Atlas will add more storage automatically to avoid running out of disk space. And also on the compute level, when it recognizes that the CPU and memory are under heavy utilization, it can trigger automatic upscale to the next higher cluster tier, right? Yeah, and you can see here you can scale storage independently from the cluster tier. So 40 GB is what comes by default with this cluster tier, but you can add more if you need just more storage and you're okay with with the compute hardware for this cluster tier, right? Okay. There is additional settings we can configure here. So it's mainly about Mongo version you want to use. So Atlas runs real Mongo DB. It's not like some imitation database that there are some imitation databases out there, namely Document DB from AWS, right? So they're not using real Mongo. They have their own code base. But in this case, in Atlas, you would use real MongoDB, right? Backup is available, obviously, so you get full cloud backup, also with the continuous cloud backup option. This means we are backing up full oplog, so operations log for your cluster. This enables us to restore point-in-time restores even between snapshots, right? I see there is a question. Christian, go ahead.
Yeah, I want to ask a question. So we do have a point-in-time recovery for DynamoDB, and that saved our assets multiple times. And I see here you support backups and recovery point objectives, you call them, right, for 1 minute. So basically, I'm interested in, right, do we pay extra to have point in time, or do we get that by default? If we just want to roll back to some, or create a new snapshot, right, or create a new database from a snapshot taken, let's say, between a time interval, because something happened during that time window, right? Do we have to pay extra for that feature, or is just always there up for you?
If you turn on continuous cloud backup, there will be some extra cost, but this is because we are backing up this oplog information. So there is some cost with storing that data, backing it up. It's not massive cost. I guess it mostly depends on how much operations you're generating, because the more operations you have, the bigger the oplog will be. And also you can specify the point-in-time restore window. So this is basically how far back we are preserving the oplog. So if you want to have 7 days worth of point-in-time restore capability, then we will need to store 7 days worth of oplog information, right? Which is will be some gigabytes of data based like how much oplog you're generating per gigabyte per hour, and then you could calculate that, right?
All right.
That was one question, yeah. Go ahead,
David. There is another one from David.
Yes. I had to move my mouse. 2 screens, moving the mouse to the unmute button. Hi. So I'm fairly new to MongoDB. I mean, everyone has heard of it, I guess, but I'm fairly new to it. And I now wonder, what is how is it different to DynamoDB? Like, in a sense, I imagine both to be a document database. I mean, I hear you say that search is somehow included in Atlas. But like, how is it different to DynamoDB? And what we use currently is Elasticsearch as well. And what does it mean for us at epilot?
Sure. Yeah. So the main difference, I guess, when you're comparing Dynamo and Mongo is like even Amazon are advertising DynamoDB as a key value database, right? So you know, Mongo data model in Mongo is based on documents, right? So guess that would be kind of the main difference on that level of data model, right? And you know, there is just much better support for querying, for indexing in Mongo. That support is very limited in DynamoDB, right? So I haven't used DynamoDB myself in practice. I obviously learned about it, you know, as part of this job. So I wouldn't say I'm an expert on DynamoDB or anything, but my understanding is, you know, that it can be tricky, you know, to run rich queries and to add like, you know, indexes and stuff like that. So all is good, you know, if you have simple queries. But when you need to do additional querying methods and stuff like that, then things can get complicated, right? Nishu, go ahead.
Yeah, just a follow-up question to David's. So I understand from your perspective how, you know, things would be different if we switch to MongoDB. But then my question is kind of focused to both you and Daniel as well, because, you know, the idea comes from Daniel's team to switch to be able to switch to MongoDB to because we want to move all of workflows data to MongoDB, if I understand it correctly. So maybe from your perspective, why are we switching to, you know, MongoDB instead of using a combination of DynamoDB with Entity API? Is it the search? Is it just the slowness? What are we missing?
Yeah, if you're asking me, so where we had problems was in syncing. So we had two data storage solutions, and then sometimes some might error out, right? Some you get an error in Entity, and then you have to you have other data in DynamoDB. This was in our case in Alpha, right? And then we wanted to have a single source of truth for the data, and the problem was why we forked, because you couldn't do flexible queries on DynamoDB. Torben, Tomislav was just mentioning that, right? And then we want to have a single source which is reliable and then flexible in terms of queries. And then we figure out kind of like Mongo should have them both because they have the search API. But our plan is to just try it out and see how that works. And hopefully if we can just migrate without rewriting the search queries, which is in right now for Entity API with Lucene, right? So if we can find something like as minimal effort as possible to do the migration. But the problems were that data inconsistencies, syncing back and forth, that kind of troubles.
Okay.
Yeah, thanks for that, Christian. So, okay, look, let's skip. So I've shown you how some of the options you have, you know, for creating a cluster, just to kind of make it more clear here, what is required. And you know, once you have all this configured, you click create cluster, and it takes somewhere between 5 to 10 minutes to get your cluster deployed in Atlas, right? So all aspects of running this cluster are pretty much handled by Atlas, as you would expect from a managed database. So and you know, we were not trying to create a black box here, so you have full insight into your cluster from various metrics. So I'm showing you the metrics view here. You can see all the hardware metrics, all the MongoDB metrics, all that stuff is fully exposed here. I always like to mention the query targeting metric here. You know what? Let me just switch to a different cluster here, because I don't have any traffic on this one here. So if I switch to another one, we'll be able to see some information here in the metrics. So demo cluster metrics. Yeah, this should be better. Yeah, so query targeting is really great, because it's like whenever I'm looking at the health of a cluster, first thing I look at is query targeting. It gives me a clear indication of how well optimized the queries are, because this gives us the ratio between scanned documents and returned documents. So you typically want this ratio to be as close to 0 as possible, right? That means there is no scanning going on. Scanning is bad, you know. Scanning means iterating through collection, trying to find documents, and it's not using indexes, right? So this is kind of great help to troubleshoot and tweak your queries. Alongside with other tools we have here, you know, we have the profiler. So profiler, you can look at every individual query that's running on Atlas. You can zoom in. So this is like one query that was executed. You can see the collection it was on. You can see all the details, right? So how much time it took, keys examined, everything, right, alongside with the actual command that was executed for this query, right? So this is great help for troubleshooting performance issues. And I also mentioned performance advisor. So this is like automated advice on things like indexes you want to create to get better performance, or even drop indexes. In some cases, I don't have any drop index recommendations for this cluster, but if you have any unused indexes, it's always good to remove them, because you're just adding overhead on the right side of things if you have too many indexes. So it just means more index maintenance needs to be done, right? But you can see here it's actually recommending me 10 indexes I would need to create to improve the performance of some of the queries that were captured by the profiler, right? Do you guys have issues with performance tweaking, troubleshooting? How does that work today? Do you have the correct tooling in place with DynamoDB?
Can I ask something here regarding this one, actually? So
Yeah.
I know that creating an index is good, but creating too much indexes can also be bad. Also, there's other way of optimizing and scaling, like sharding and this kind of stuff. So how would the DynamoDB would act on this kind of performance optimization and the scaling?
You're right. Yeah. So it's definitely not a good idea to create too many indexes here. So like a rule of thumb, somewhere around 5 is typically a good number to have on a collection, and yeah, so it's always about finding the balance, to have a good read performance and not compromising your write performance, because too many indexes will slow down write operations. But this is actually why search is proving to be such a success, right? So when we talk about Atlas Search, so it's a search engine that we integrated with MongoDB under the Atlas data platform, right? So any search index you create, you're not creating a MongoDB index. You're creating a completely different index structure. On the search engine side, inverted indexes, different stuff than you have in the database, right? So this can really be great, because a lot of use cases I've seen, people were struggling in finding the correct index strategy. They needed a lot of different variations, different indexes for this or that, and that could put a lot of pressure on the performance, right, of the database. So Atlas Search can really help with that. David?
Yes. So I think I didn't get it in such a good detail, the differences. Like I would assume you also integrated some sort of open source technology when you develop the search capabilities, maybe like iSearch or Elasticsearch or whatever. So how is this helping us handling indexing better than Elasticsearch, for example?
Sure. Let's skip to this. So I'm showing you a page. Sorry, Ahmed, did I answer your question? So
Yeah. In general, yes.
Yeah. Okay. You mentioned sharding as well, right? So sharding is like, you can horizontally split your data, partition your data, and that to kind of split the whole processing, right? So because in a single cluster, in a single replica set, all the processing is happening on a single node, the primary node. But if you have a sharded cluster, you have multiple shards, and each shard is a replica set in its own, right? So each shard will have a primary, and it will manage a portion of the total data. So you could split or kind of introduce more parallelism in your processing with sharding, right?
Yeah, but also it has its own downsides also, like it's really hard to maintain these tables when it comes to like sharding, and also like changing something might affect really like doing a cascade changes. So it's really hard to maintain all of these together, at least from my perspective.
That's absolutely true. Yeah, there is a lot of complexity, when you have a sharded cluster, more components, moving parts. But I've heard from people that they don't want to do sharding outside of Atlas, because Atlas makes the whole thing much easier. All the operational aspects are taken care of by Atlas, so it kind of makes it manageable and easier. So you're only left with some responsibility on how you want to split your data, and obviously optimizing your queries to avoid things like scatter gather queries. So those are the queries which would fetch data from multiple shards and just adds more latency. Yeah.
Yes, you're right.
Okay, cool. So look, talking about Atlas Search, let's kind of dive into the actual architecture. This is a page from our documentation. I think it had this good diagram here, or like architecture overview. So I can zoom in a bit if you can't see this well. So what happens when you want to use Atlas Search? So everything starts with this Mongo D process. So that's your standard Mongo server process. Once you create a search index configuration, and I'll do that in a few moments to show you how that is done, Atlas automates creation of extra components here. Mainly, we're talking about this another process we call Mongo T as text search. And so David, you were asking about which technology we use. So we use Lucene, right? So Lucene is the open source search engine library written in Java. So we didn't want to reinvent the wheel, like try to build this from scratch on our own. Why not use, what's already out there? It's, industry standard. Elasticsearch is using Lucene as well. So we used Lucene and integrated Lucene with MongoD process, with the Mongo server process. So when you create index definition, we copy all the data that is required on the search side, on the search process side, and we set up for this change stream notifications. So change streams is MongoDB's native mechanism for notifying subscribers to changes in the data. Like insert, update, delete. You can get notified. So this is actually utilized here for search. So whenever something changes on the Mongo side, we can push those changes in near real time to the search engine side. So we are minimizing the consistency gap between the database and the search engine, right? Another beauty of this design is that all the querying you're doing to the same API query API of MongoDB, so Mongo query language. So there is no separate connection, no separate query language you have to use. So if you know how to work with Mongo, it's literally just adding another stage in the irrigation pipeline. I'm going to show you that as well in a moment. $search, and then Atlas automates everything here to get the data from the right process and to return results as a single unified result to you, right? To your client, be that your application or your shell or whatever else, Does this make it more clear how things work? Yeah.
Yeah, much
Yes,
better.
thank you.
I understand the overall picture a little better now.
Okay, great. So let's see how we can do this, right? So if I go back to my Atlas here, so I have my demo cluster, and I have some collections here. So I've imported some sample data sets that we have available. It's just loading. So this isn't probably your best bet, if you want to do kind of querying, but it's an easy view. It's built into Atlas, so I like to use this. I don't have to use other tools and stuff to kind of access the data. For some reason, it's being slow now. It's usually not that slow, so I'm not sure what's going on.
We call it the demo effect.
Yeah, demo effect, right? Okay, these are some of the databases I have in the cluster. So I have this sample mflix database with a movies collection. So you can think of IMDb, so it's a collection with movie information, basically, right? And let's say I want to enable this for search. So I want to use some of the features that search has, and things like fuzzy matching, things like highlighting, scoring, all those things that when you think about Google, you have Google. When you're searching in Google, you get recommendations, autocomplete, you get typo tolerance, right? You get highlighting in results. So all those features are available with Atlas Search as well. Let's create. So this is taking forever to load. Not sure why, but let's create a search index on this data. I'm not sure. Is it my internet? You can hear me well, right? It's not my connection, right?
Yeah. No, we can hear you well.
Yeah.
Yeah. Okay. So to create a search index definition, I would go here again to my cluster. I left the other tab to load. So go to the search area, and you can see I already have some search indexes defined, because consider that we are not automatically indexing everything you have in Mongo for the search engine. That would be wasteful and kind of stupid, right? Because you're not searching on everything. So you need to explicitly create a search index for the data you want to use on the search engine side. So this is what we're doing now, right? So I'm going to click on create index, and keep in mind, whatever I'm doing here in the UI, we have an API in Atlas, so you can automate all this stuff. You can use the API, you can use the CLI, different kind of programmatic methods to achieve things in Atlas, right? I'm going to use a visualizer just to kind of better visualize what we're doing. So I need to select my collection. Again, I'm using sample mflix database and the movies collection. I need to give a name to my index. So I already have a few indexes there. So I'm just going to use some creative name like default 30. Yeah. You can have multiple indexes on a single collection. That's perfectly fine. Or you can add more fields to a single index, right? So consider that you can only evaluate a single index for one query, right? So if you have a query that needs to evaluate, let's say, 5 fields, you would want to create a single index with those 5 fields inside that index to be able to use that for your query, right? So I guess indexes will be best aligned with your query patterns, with your queries, how you're running, which queries you need to run, right? Okay, so give index a name, and then so this will be familiar as like Lucene standard, so analyzers and stuff like that. So anyone who's used to working with Elastic will recognize this, because we're not hiding the fact that we're using Lucene. So we're exposing some settings from Lucene that you can configure here to tweak your indexes according to your needs, right? I'm gonna click here on refine your index, and I'm gonna turn off this dynamic mapping. So this will automatically index all my fields in my collection. I don't want that. It's typically not a good idea, unless there are some use cases, where you have a very variable documents. So you don't really control the schema. Let's say customers can create their own documents, some forms or stuff like that. So then you could use this dynamic mapping to automatically index everything and enable a search on all the fields that customers create, right? The fields you don't know ahead of time when you're creating the index. But in this case, I know which field I want to search, so I'm going to switch off dynamic mapping, and I'm going to add kind of a specific field here. So the field I'm going to use just for the purpose of this very simple demo is title. So that's like movie title, right? And you need to choose your data type. So you can see that we have multiple data types here, and it's not just about strings actually, right? So look, we have booleans, we have dates, we have numbers, we have geo information here. So Atlas Search enables you to search all these data types. You can search numbers, dates. You can search geo information, like point search. Find me something that's near a location and stuff like that, right? All of that is available. I'm going to use autocomplete for this. So you might wonder what's the difference between string and autocomplete. So autocomplete is kind of similar. It works with string data, but it does more stuff during the index build time. So the index that will be created, it will have more variations on your data, so that it's much faster in runtime if you're trying to achieve those autocomplete features, like recommendations. When people type, you want to show them some suggestions as they type. So autocomplete is better suited for that type of scenario, because more work is done during index build time, so it's more performant in runtime. Yeah, you could achieve similar stuff with string, but it wouldn't be as performant. So that's why we have the autocomplete here. Okay. Apologies if I'm going too fast. I'm just kind of keeping an eye on time. I know we have limited time, so I just want to cover this fully, right? So there is tweaking options here. Again, this is all coming from Lucene, so I won't go into all these details. You can tweak this according to your needs. But for now, let's just add this field. So we have our title field added to our index, and that's pretty much everything I'll do here. We have synonyms as well. you know, you could add synonyms like beer, you know, or pint, or, you know, keg, stuff like that. That's kind of typical example we use, you know, if automobile, car. So that's what synonyms can do, right? I'm going to click Save Changes, and then I'm going to click Create Search Index. And Atlas will now automate all that stuff that needs to happen in the background. You can see that we have our new index here, but it's not yet active, so it will take a few moments for Atlas to index everything. Yeah. While that is happening, I'm going to go to our documentation here. So we have really good tutorials here on how to use Atlas Search. And one of these tutorials is how to use autocomplete with Atlas Search. So I'm just going to copy one query from this tutorial. So we already went through all this stuff around creating the index. So we've already done that. And I'm just going to skip down to find my query. And here it is. So yeah, this is your normal MongoDB irrigation pipeline query. Okay, so this is how you run irrigations in Mongo. So irrigations is like a more feature-rich framework for querying Mongo. You have your basic CRUD and search operations like find command, you know, but it doesn't support things like group, sums, and stuff like that, right? So this is what you would use irrigation pipeline for. You can see here that I have a $search stage. So irrigation pipeline, the pipeline means, you know, we have a pipeline of stages. So you have multiple stages here. So one stage is this $search stage. So this is where I'm invoking the search engine. And I'm using the autocomplete operator, specifying title as my path. So that's the field I'm using. And this is the query I'm sending to the search engine, GER. So as people type in your application GER, this is you could just, you know, call this irrigation pipeline on Mongo, and you will get some suggestions, you know, you can offer to your users as they type. I also have two other stages here. Limit stage, I'm just saying I want max 20 documents returned, and I have $project. This means I can specify which fields I want to return from my document. I don't want everything from my document to be returned. I'm just returning the title field here, right? So if I copy this and I go here to my data view, okay, unexpected error. So that happens. Let's try again. So yeah, it's much faster now. Yeah, there was some glitch or something. Yeah. So let's go to sample Netflix. Let's go to movies, and you can see I have this irrigation tab here where I can build my irrigation pipelines. So this is kind of nice UI to help you with building your pipeline. But if you have your query already, you can just kind of use this text option, and then you can paste it directly here. So I'm pasting my pipeline here. You can see there is no preview documents, and I just realized why that is happening. It's because I didn't specify the index name, right? So you saw I have multiple indexes on my collection. So by default, it's using index called default, right? So if I want to use a specific index, I just need to put index name here. So index, you remember we were using default 30, yeah? And let's put a comma here to make it a valid JSON document. And yeah, you can see we're getting some results back, right? So Gertie the dinosaur, Germany year 0. So everything that basically has GER. So this could be some suggestions in your UI. As people type, they could just select one of the options that you're offering to them, right? Okay, this is kind of end of very fast and simple Atlas demo that I was running here. So I've shown you how easy it is to create a search index. Obviously, there are multiple options there. You saw you can tweak things, you know, analyzers, min grams, max grams, all those different things, right? So you know, you can achieve things and tweak things according to your needs. But on a high level, it's very simple, right? So you have your data in Mongo, you have your Atlas cluster. When you need search, you create a search index, and there's nothing else you need to do, nothing else to provision, no new query languages to learn, nothing like that. It's literally using the same Mongo query language to use search, right?
I think Nishu, you had a question, right?
Go ahead.
Yeah, thanks. I wanted to ask, so we extensively use dynamic mapping with Elasticsearch in, all of our searches. So if you could share maybe a little bit more on that, I'll give you the context. So in most of the dynamic mappings that we are using, usually happens that, we have a lot of mapping challenges with Elasticsearch. For example, the first field defines one index, one type, the field becomes a date type, and then there's some other data, and then, it messes up mapping. So we've had those challenges a lot. There was one specific issue related to date and text mapping for which we also reached out to Elasticsearch, but there's similar issues. I want to know if it's the same, if it uses the same, logic under the hood, and it's going to be the same issues, or how does it work?
I mean, we have specific rules about how data types are mapped between Mongo and Lucene, right? So I'm not aware of any issues people having around this area, right? So it typically works well. Once you could use it in the dynamic mapping that I shown you there with search. So Atlas would automatically index all your fields in the collection based on some rules. Data type conversion rules that we have, right? So I don't expect any problems in that regard now. The beauty of all this is, it's managed for you automatically. So we're kind of investing a lot of engineering effort into all this synchronization element. So I know how you guys said, this is some area, Kristen, you said, this is where you are struggling a bit occasionally, right? So, the whole point here is like, leave this to us. You can focus on other stuff that matters for your business, building new features, stuff that will make your product better, instead of trying to kind of figure out, how to do proper synchronization between database and the search engine. So this is taken care of by Atlas for you, right? If there are some issues, obviously you can imagine, we have our whole engineering organization behind this. We're always keen to fix everything, but I can kind of give you some inside information that we're really kind of proud about this product, and we see a lot of benefits in people using it, and we have a lot of customers who are already using this in production, in their applications. So I don't see any issue there.
Tomislav, one thing I see, Paolo, you still have one question, and I think then we're landing on point. If you still want a last question, maybe answer that.
Yeah, go ahead.
Yeah. So you explained to us how easy it is to create new clusters and all that stuff, but how easy it is to migrate our data from any other database solutions to MongoDB, or what are the most common challenges that organizations can find?
Yeah, that's a broad topic, the migration one. So yeah, look, it all depends on how your data is currently organized, right? So it can be more challenging or less challenging to migrate that. But we have like a lot of expertise in this area. So we have experts in the company who've done this for multiple customers already. You can imagine you're not the first company who are considering doing something like this. So yeah, we have experts. I'm not an expert in migration, but we have experts in company who've done this before and can offer like support and tooling and all those things that would be beneficial to make it as easy as possible, right?
All right.
Awesome. I think, Nishu, we are on time, hopefully.
I mean,
you want to close it? Yeah.
If
or maybe
if anyone has any more questions, feel free to ask now or always. I think you would also want to answer some questions if they're or just like anything to close it with.
Yeah, I think just for you, I will also, Nishu, send you like a quick overview with everything that was discussed today. So you also have the documentation and everything. Also, we have some credits. So if you say, hey, maybe on a private project, you want to try it out, feel free to do so. Also, again, if you say, hey, for one of your projects that might be interesting, feel free to reach out to us as well. And I think, yeah, we see how we work from here. And also, Christian, if we get the time, then also for the first project, maybe run together here.
Yeah, it would be cool.
But yeah.
And yeah, it would be great if you could share the links, maybe the credits for a beginner project, for example. We could already share it within the organization. And, I think that would even more motivate people to try out something on the side.
But yeah, really appreciate your time, all of you, and also Tomislav, thank you so much for helping out today.
Thanks, everyone.